Hello, viewers. Welcome back to Vinrays Academy. This is Vinay. Today, we're exploring an exciting frontier in software testing, how machine learning can revolutionize your QA processes. In this video, we will look at how to train machine learning models for QA, how to apply them in testing workflows, and the many ways ML can help you optimize and automate. Whether you're new to ML or looking to advance your skills, stay tuned. Let's dive in and start learning. Machine learning, at its heart, is about using algorithms that can learn from data, making decisions based on patterns. When applied to QA, machine learning allows us to automate repetitive tasks like generating test cases, prioritizing them, and even executing those tests in smarter ways. Unlike static automation scripts, which repeat the same actions, machine learning models improve over time. They get smarter by learning from your test data, enabling more accurate predictions and better coverage. Think of it as having an assistant that gets better the more you work together. The beauty of machine learning in QA lies in its ability to continuously improve. Imagine running your tests and automatically knowing which areas of the application are most likely to have defects based on historical data. This allows you to focus on high risk areas, prioritizing testing efforts more intelligently. ML models can generate new test cases, predict failures before they happen, and even adapt to changes in the code base. The more data they have, the better they become. Unlike traditional approaches, which need constant manual updates, machine learning learns from its environment and evolves with your application. Now, let's get into the heart of the process, training an ML model for testing. The first step is gathering relevant data, which includes your previous test results, defect logs, and even performance metrics. This data forms the foundation of your model. But raw data is often messy, so you'll need to clean it, removing irrelevant information, correcting errors, and standardizing formats. Next, choose an appropriate algorithm based on your goals. You might use decision trees to categorize test outcomes or neural networks for more complex decision making. Finally, after training the model with your data, validate its performance to ensure it's making accurate predictions. This process may take time, but the benefits are worth it. Let's put theory into practice with an example. Imagine you have an application with hundreds of test cases, but limited time to run them all before each release. You can use machine learning to prioritize those tests. By analyzing historical test data, your model can predict which parts of the application are most likely to fail. It prioritizes those test cases, ensuring that your testing efforts are focused on the highest risk areas. Over time, the model improves, refining its predictions and making your testing process faster and more effective. You don't always have to start from scratch when integrating machine learning into QA. Pre-trained models are widely available in libraries like TensorFlow and Keras. These models can be fine-tuned for your specific needs. For example, you can use a pre-trained model to detect anomalies in your application's behavior, such as unusual API response times or unexpected error rates. By leveraging these pre-trained models, you can significantly reduce the time and effort needed to get started with machine learning in testing. Once your machine learning models are trained, you can integrate them into your existing automation framework. Whether you're using tools like Selenium, Cypress, or others, ML can complement your current methods. For example, you can feed insights from your ML models directly into your test scripts, automating which tests to run and when. This makes the entire testing process more dynamic and less dependent on static rules. By blending traditional automation with machine learning, you create a smarter, more adaptive QA environment. Like any technology, machine learning comes with challenges. The biggest is ensuring data quality. If your model is trained on poor quality data, its predictions will be inaccurate. Regular monitoring and updating of models is essential to ensure they stay relevant as your application evolves. And while the initial investment in machine learning, whether it's time, resources, or training, may seem high, the long term gains in efficiency and accuracy make it worthwhile. To wrap things up, machine learning offers tremendous opportunities to optimize your QA processes. Start small, perhaps with a single test case or task, and build from there. Whether you're using pre trained models or creating custom ones, the key is continuous learning and iteration. Machine learning in QA is a journey, and the more you work with it, the more value you'll get out of it. Thank you for watching, and don't forget to subscribe to Vinrays Academy for more tutorials and insights on AI, ML, and QA.